So that's great. But what happens if you don't have a two-dimensional data structure? Well, another way to move through your data tree is to use the path mapper. This allows you to perform lexical operations on data trees. Oh, well, what are lexical operations? Those are mappings between an input and an output data path where we can specify with a textual mask a new or redefine the original data path. So if I have A, B, and C, right, how can I say, let's say I want to remove B. So I just want A and C. So in the case of, let's say, our surface, we had a surface. Oops. We had points, which were at this level, organized in U and V. And then if we graph them, we would have each point individually. What if we said, I don't want the data tree to remember that we're at the level of the U and V. I just want to relate it back to the surface. So you could remove B by specifying that A, B, and C become A and B, which is your lexical mask, and then reorganize the data structure itself. All right, so what does that look like? If we go back to our file, and we're at the end here with the param viewer, and we're going to come back to the gradient object in a second. There was a question about it. But let's work with our path mapper. Right? The path mapper says that we can say whatever comes in will get redefined based on our mask. Right? So if we go to sets tree path mapper, drop that in. This is a kind of funny looking object. What we do is we connect our data stream into it, right click and say create null mapping. This auto-populates the data structure as it is coming in and as it is coming out. Notice how we've been using the same letters as placeholders describing our tree thus far. A, B, and C. So if you do a right-click null mapping, that means that there's no change between the input and output. So nothing's going to change as a result, right? And so what we're going to do is we're actually going to edit this relationship so that we're redefining the data structure. Now, the way we're going to do that is double-click it, and now we have this new window pop open that's labeled Lexical Combo Editor. So bonus question. What other letter are we not using that we've been talking about? We have A, B, C. Based on the param viewer, all right, there are a couple of suggestions for I and a couple of suggestions for N. Here, N is telling us there's the number of items on this list. So there's one item. Conventionally, we'll call that I. So you can put in whatever you want in here, but we'll use I to be consistent. So the lexical, the null mapping coming in is curly brackets A, semicolon, B, semicolon, C, close curly brackets. So to the source, we're going to add open parentheses, I, close parentheses. And in the target, we'll do the same. So you have now, nothing will change if you hit OK. I is helping us identify the objects in the list as opposed to the path indices. Now this Lexa combo editor will actually allow us to do every basic manipulation that we already did: flatten, graph, simplify, and shift. It's just that we have to specify it manually. So it's really powerful and it can do a lot of things. The other ones are really great when you know that I want to graph instead of having to type this out as an example. All right, so we're going to hit OK. And now again, nothing should have changed in your param viewer. But now this is fully set up for us to do a manipulation. All right, so it's ready for us. Now, there was a question about the image sampler and how it's working. The image sampler is a convenient way for us to relate something in a two-dimensional context, let's say points that are on a surface, to a set of values in an image, right? So if this is the corner 0, 0, and this corner is 1, 0, 1, sorry, 1, 0, this is 0, 1, and this is 1, 1. That's a kind of space that we can navigate through in order to query the pixel data at any particular location. When we specify brightness, it gives us a value between 0 and 1 that correspond to black and white, respectively. Right? So what we've done is we've essentially plotted points inside this image sampler by using the surface UVW coordinates, and then returned the 0 to 1 values that are defining brightness. Right? So if I'm looking at my surface, down here we're relating points to the white values that are in this corner and the black values up here in this corner, and all the gradient values in between. So it allows you to make smooth transitions when you make a gradient in Photoshop across extremes being white to black. All right, so it takes color information and gives us numbers as a result. And numbers we can use to define things like how big the offset should be between the two surfaces. All right, so in this case, we're able to make any modification to these. Now where we're going is that we want to make a connection between the lower curve and the upper curve. We're going to do that through a loft. All right, so if I grab the loft object from surface freeform loft, it takes in a set of section curves, right? So the section curves are the things that I want to define the profiles as for my loft. So if I just wanted to go from here to here, that's pretty easy. I think you can guide me through it. I have two streams. How can I get those two streams into this loft object? Go ahead and hit me up with an answer in the questions pane. I want this curve and this curve to loft to create a loft right here. So I have a recommendation to hold shift and connect. That can work. Anyone else? Merge. Let's use the merge. I like the merge because the merge actually shows you the order in which you've specified those wires should be added to one input. So that's under sets tree merge. And I'm going to put this curve into D1 and this curve output into D2. It will auto create another input, which I'll zoom in and remove by hitting X, or the negative sign. So now I have lists of two curves, right? So if I connect that across, I'm probably not too surprised as what I get here. I get some fins. They're connecting one profile to the other profile. But now comes the trick. I have a data, or the challenge. I have a data structure, right? Our rule of thumb for today is that we're not going to flatten anything, right? So we're not going to be working at list levels for any reason. We're going to be working at tree levels or paths. So how can we actually say, I want to connect this profile that's at the top here to this one here, just by using the data trees? Well, the way we can do that is say, well, let's redefine how the data paths are labeled. So if we go to the param viewer, the path mapper, double click, and in the target, we're going to do C plus 2. Now this is our little rule to redefine our paths. I want to take the upper level curves, which are here, and I'm going to shift them so that their C index has a 2 added to each one of them. So it's C plus 2 is our little expression. Hit OK, and now replace the input of D2. All right, what did we get? We got kind of fins that are connecting from one curve, not directly below, but across to the path that's labeled here. Now, this one was 0, 0, 0, 0, 0. Now it's 0, 0, 2. Down here, this is 0, 0, 2, so it's going to get connected across. So there we create our loft. The letter combo editor is the path mapper, which is from sets tree. It's this little box icon. And again, to refresh, we connect it, right-click, create null mapping. Now we can double-click it to modify our target path. Okay. All right, so does everyone understand why we're connecting now across data paths? Because we're connecting what was 0, 0 to now 0, 2. Notice the param viewer changes. There's no 0, 0, or 0, 1. So those lines, those curves there don't have anything to connect to. All right. Now, challenge question. Why is the graphed object red? All right, well, if you put your mouse over the, someone said lonely curves. That's exactly right. If you put your mouse over the little bubble that pops up, you'll see insufficient valid profile curves. What happens as a result of our merge, because of our manipulation to the data structure, is that the first couple and the last couple of data paths, they don't have a friend. So there's only one curve per path. And we can't create a loft from just one curve. All right, so what we're going to do is we'll use another more advanced data tree object, which is called the prune sets tree prune tree. This removes small branches from a data tree. So we'll connect our merge into D for our data. And N0, it says remove branches with less than N0 items. So if we specify a panel and say 2, we have to have a minimum of 2 for our loft. Connect that to N0. Now, if we replace the input of C, we now have a happy loft because there aren't any paths anymore that have just one curve. They've been removed. So the first successful path is 0, 0, 2. All right. So that is the kind of flip to path mapper and with a little utility like prune sequence for how you start to manipulate your data trees. And again, this allows us to restructure the data paths, not changing the data that's there itself, right? It's always the same curves before and after the path mapper. It's just that they're organized in a different way. And because data trees are hierarchical and because we can manipulate them, therein lies the power of data trees. There's a hierarchy that we can access and redefine and thereby creating new relationships either along the data path, kind of moving vertically through the data structure, or laterally through the data structure by associating, let's say, this item to this one over here. All right.